Alright, I'm welcoming us back from lesson 2A. By the end of 2A, we were able to factorize simple algebraic expression. In this video, we're going to factorize large algebraic expression. I just want to believe we are set for it. Alright, let's consider this following set of questions. Let's see how we can factorize them, A to F. Now, the approach here is you first ask yourself, how many terms are there in the expression I'm dealing with? Here on the screen we have x plus x into y minus z, just like you can see it on your screen. So you ask yourself, how many terms are there in this particular work I want to do? Okay, now when I mean terms, I think I can see a lot of terms here, but the number of terms based on the bound of multiplication sign. Alright, take for instance, this is an x, and x is just alone here. It's not multiplying anything, probably multiplying an invisible one. Here's another x here. Now, multiplying these whole brackets. Okay, so that gives two terms already. There is a x here multiplying an invisible one. There is another x here multiplying these whole brackets. With that, I can see I'm having two terms. So, y, this x is multiplying 1, then this plus s is multiplying these whole brackets. So, I have a term in white and I have the other terms in gold. Okay, now the question is, if this is a term and these are other terms, so what is common to this white and this all in the gold? I'm having an x here and I'm having x into y minus z there. So what is common to both? What do you think is common? I think a s is common. Wow, a s is common. Okay, now that's why I'm writing out a s. If x is common, then let me open a bracket and let me bring out x here. So what am I going to do? I'm going to bring out the term in white and the term in what? The term in gold. Then divide both terms by the x I brought out here outside the bracket. So I'll be having divided by x. So these two x are from this source. This s is from here and this s is also from here. That's just the techniques. So by the time I'm done, I will do a division. S cancels s. Then I will be having 1 here. And here s cancels this s. Then I will be left with what? Y plus z, the one in gold. Then I close my brackets. Now, by the time I open this bracket again, I'll be back to what I'm having here. And with that, I've done my factorization. Okay, we'll see more examples and we'll see how simple it is. Okay, it's very simple. Don't worry, you will get everything clear. So that is example 1. Now let's come here for example 2. Okay, now example 2 here, I'm having 5 into x plus y, close bracket, plus b into open bracket x plus y. Okay, I said you look after the number of terms based on the bound of multiplication sign. So, if I may ask, how many multiplication signs do we have here? I think we have 2. There is a multiplication sign between x and this bracket. Sorry. There is a multiplication sign between 5 and this bracket. And there is another multiplication sign between b and this bracket. Yes, invisible. Of course, you should know they are multiplying themselves. So, based on that, we can say we have 2 terms in this expression. Okay, just for the sake of factorization, we have more than 2 terms, alright? But for the sake of factorization, we assume we have just 2 terms. Now, so if really we have 2 terms, so let's distinguish them by the use of color. So we have a term appearing in white, and we have another term appearing in gold. Just like we did in example 1. You can go back to that example 1 so that you can understand better. So, if that is that, now you ask yourself, for the term in white and the term in gold, what do you think they have in common? I don't know if you can see, but me I can see here, I'm seeing x plus y with 5, multiplying 5, I'm also seeing x plus y multiplying b. So it means that x plus y is common to both terms. And if x plus y is common to both terms, then let me bring out x plus y as a common factor. Then use the factor now to engage what I have in the brackets. So how do I engage? So I will bring out the term in white, then I will divide it by this, x plus y. I will also bring out the term in gold, just like you can see on your screen, and divide by the factor x plus y. And that's what you will see displayed on your screen. So this x plus y, this 2x plus y, sourced from this. Okay, now by the time we are done, I'm having this x plus y outside there. Now let me follow my square bracket. The x plus y here cancels the x plus y here. Yeah, I'm permitted. Then I can have my 5 left. Then this is an addition sign. I bring it down. Then x plus y also cancels the x plus y here. You agree? You can see the use of the slash I'm using to cancel out, just for proper understanding, and I'm left with b. Then I close my square brackets. So by the time I reopen the bracket, I can have exactly what I'm having here. So let me get rid of all those rough workings, because of course they are rough workings. You don't need them. I'm only using them on screen for you to have a better understanding of what I'm doing. So here is my final answer. So I already have this factorized, and this is a factor expressed there. So if I were you, I will use a bracket here for x and y also. That will present your answer better. C, I'm having 2x minus 3y in a bracket, then 5z. And here I'm having 2x minus 3y squared. Okay, so what's the question to you back? How many times do you think we're having now? Based on the bond of multiplication sign. How many? Any answer? I think it's still 2. Huh? Yeah, it's 2. So let's distinguish them by the colors. So we have one in white, we have a term in white, and we have another term in gold. So if that is true, then let's see what do they have in common. But before we examine what they have in common, this look bond or clumsy, the value in gold, loose bond in a way. So let's split it, let's break it down. And breaking it down, we can have 2x squared minus 3 all squared can be expressed as 2x minus 3 into 2x minus 3. Yeah, that is the expression. So in a better way now, we are still having 2 terms. Do you know? We are still having 2 terms because everything in gold are still bound by what? By multiplication sign. So if you agree with me that we are having 2 terms for the sake of this factorization, if we are having 2 terms in the whole expression from here down to here, now you will agree with me that the common factors to both terms is 2x minus 3. I know you will agree. Because you can have 2x minus 3y here multiplying 5z. And here you can have 2x minus 3y multiplying another 2x minus 3y in gold. So it means that 2x minus 3y is common to both. So if 3 is common to both, then I can have it out here for factorization. And if that is the case, then let me open a square bracket. So opening a square bracket, I'll be writing every term in white. So that's everything in white. Then everything in gold is also coming out. Just like we have it come out on our screen. And if that is it, then let's divide both terms by 2x minus 3y, which happen to be a factor. So 2x minus 3y, 2x minus 3y. Dividing both. So what do you think we're going to be having left? So I'm having 2x minus 3y, open our square bracket. So for the values in white, what am I having left? I'm having 5z. For the one in gold, what am I having left? I'm having minus 1 of the 2x3y. Just by the slash you can see I'm using. Then I close my square bracket. Why? Because by the time this cancels one of these, then I'm left with one of it, and that's why I'm having it here. So what other thing do you think I can do? There is no other thing I can do. So I've done a factorization work, and I can just get rid of all this rough work, and we're fine. So here is the answer to my question. I can just try and use a bracket here to make my work more presentable, I think. Now in our day we are having just exactly what you're having on the screen right now. By now you should agree with me that on the screen you're having two terms. There shouldn't be a doubt about that anymore, I think. So let's distinguish those two terms by different colors. Then I have a term in white, and I'm having another in gold. Now the next question is, the term in white and the term in gold, what is a common factor? We are looking at it. Do you have a common factor? You know, somebody is saying yes, but I'm not sure if it is yes. Alright, I'm having an x squared here multiplying 2 minus x. Here I'm having a minus 4 multiplying x minus 2. So, does it look like we have anything in common based on what we've been doing before? Question? Of course no. We don't have anything in common. Here is 2 minus x, here is x minus 2, here is x squared, and here is 4. Nothing in common. So what do you now observe? I'm observing something that looks like the same thing, but not exactly the same thing here. I'm having 2 minus x, and here I'm having x minus 2. So, like here I'm having what is a direct additive inverse of what is there. Additive inverse. Okay, I think I need to expatiate on that for better and clearer understanding. Additive inverse of a x coming up on your screen is minus x. Okay, additive inverse of x is minus x. Now, additive inverse of a 3 is minus 3. Okay, now the additive inverse of, x plus y is just equal to minus open bracket x plus y close brackets. So, in a nutshell, anything you will have to evaluate that will make that value a 0 is just the additive inverse of the value. Take for instance here, this minus x, add minus x to x, you are getting 0. This is minus 3, add minus 3 to 3, you are getting 0. Now the value here, add it to what you are having here, you are getting 0. So the additive inverse is just put a negative in front of that value. You have the additive inverse of the value. Now, you can now expand this bracket and still have it expressed as minus x minus y. By the time you open this bracket or simplify the bracket, you have this. So, now how does it affect our question? Here I'm having x minus 2. The additive inverse of x minus 2 is minus open bracket x minus 2, of course. So, I can have the same value expressed as minus x plus 2. By the time I use this negative to open the bracket, this is what I will be having. So I'm just trying to establish the fact that 2 minus x is an additive inverse of x minus 2. Going somewhere, you will understand. So I'm just showing you how to get the relationship between a value and its additive inverse. So if that is the case, now let's assume in the same question, you are having something like this coming up on your screen, and you have to factorize. So you are having a q here multiplying x minus 2. You're having a y here multiplying 2 minus x. So x minus 2 here is an additive inverse of 2 minus x. How are you going to address this situation? So you're going to do is either you change what you have here to x minus 2, or you change x minus 2 to 2 minus x. So you change one to the other, because one is just an additive inverse of the other. So how do we change a value to its additive inverse without causing problem? We need to expatiate on that also here. We may need it somewhere. So let's go further and let's see how we can be helped in this matter. Having what you have on your screen now, q multiplying x minus 2 and y here multiplying 2 minus x. So what do I want to do? The intention is I want to deal with x minus 2 and change it to its additive inverse here, 2 minus x. I will say that again. I want to change x minus 2 here and change it to 2 minus x here, because this is a direct additive inverse of one another. So that I will be able to have a common factor. So how do I do that? I will do that by introducing a minus like you see me do in previous explanation. Now, this is q multiplied by x minus 2 then plus y open bracket 2 minus x close brackets. Okay, now what do I want to do now? I want to divide this bracket by minus 1. I'm saying that again. I want to divide this bracket x minus 2 here by minus 1 so that I can get 2 minus x. And let's see how I will get it. So dividing that bracket by minus 1. That is, I'm just trying to say that minus 1 is common to both x and minus 2. That's what I'm trying to bring out. Minus 1 is common to both x and minus 2. That's how I can divide using minus 1. Then bring out minus 1. You see it's coming out in gold. So it's not very clear. Then open this bracket, just the normal factorization that you're used to. That's what I'm doing here. Then divided by minus 1 and divided by minus 1. That's just what I'm trying to do. I believe someone is not confused. All I've been trying to do is I am dividing this bracket by this minus 1 so that I will be able to have x minus 2 the same thing as 2 minus x. Okay, let's move on. Plus what I'm having here. So there is a reason why I'm not disturbing this bracket. Is because this is what I want to change to this. I want to change x minus 2 to 2 minus x. So let's see how it works out. And I'll be having q multiplied by minus 1. So if I should do my division, what am I going to get? This is x divided by minus 1. What do you think that is? That's minus x. Now this is minus 2 divided by minus 1. Negative cancels negative, and I'm having what? Positive. Then 2 divided by 1 is 2. So after my division, this is what I'm having in my bracket. Minus x plus 2, that's what I'm having in my bracket. Then plus y, open bracket 2 minus x close brackets. Okay, then I'm multiplying my q by minus 1 already outside, so that's why I'm having minus q. Then the next thing is to write out what I'm having in the brackets. So what I'm having in the bracket is already 2 minus x. If you can see it well, this is plus 2 minus x, and it's already the same thing as this. So I'm already having 2 minus x, which is what I want to achieve. So this is 2 minus x, then plus 2 minus x. If you don't understand the process, just go back and listen again. I tell you, you're going to understand. You're going to understand. Or wait for another example and just try and bring things together. It's simple, okay? All I did is I used a minus 1 to divide the bracket I want to change to the order additive inverse. That's all I've been doing. So now I have a common factor, yes? But it has been a tug of war. But don't worry, it's not a war, okay? You can get it. 2 minus x is common. I'm bringing out my 2 minus x, and inside my bracket I will be having minus q plus y that are outside. Then readjusting my work, I'll be having minus 2s open bracket y minus q, just rearranging what I have in this bracket. And this is my final answer. This is my final answer for this example. Now this is just an instance, but let's go back to our working page and let's solve our question. It has been a moment of deviation. Alright, we're back to the page now. So what do I want to do? I want to change x minus 2 to 2 minus x. That's what I want to do. I want to change x minus 2 to what? 2 minus x. I'm having, how does it work? I'm having plus 4 into x minus 2. Sorry, I'm using a different font of x. Okay, but they are the same thing. So if I can just quickly show you what happened there. I brought out a negative 1, a minus 1, and use it to divide the brackets. Just as you can see it on the screen. I use a negative 1 to divide what I have inside the bracket. So after using that negative 1, then that negative 1 multiplied by negative 4. That's why you are having this positive 4. Then divide what you have. Divide x by negative 1. You are having negative x. divide minus 2, negative 2 by negative 1, then you are having what? Negative 2. I just want to believe this is clear. Rearranging what I have on my screen, I'm having plus x, then here is 2 minus x. I know you agree with that. That's 2 plus 2, then minus x. Just rearrangement, nothing. Then I can have 2 minus x to be a common factor. Then I'm having s squared into 2 minus x, then plus 4, open bracket, 2 minus x. Then let me do my division. I believe you understand what I'm doing here. The previous work. All I've been doing is just to get a common factor. That's all I've been doing. So, after doing my division, I'll be having a s squared, then plus 4. That is my answer. And can get rid of. So I can get rid of this rough work and just bring my final answer up here. So let's go to another question. This is E. E is similar to this work, but let's see how it works out. In E now, you agree with me now that I'm having 3 terms. 3 terms. Yes, I'm having 3 terms. These two are connected by multiplication. X plus y is a term. Minus x squared is a term. Different terms. Okay? So I can't just match them together. I'm having 3 terms now. So, but I've matched these 2 terms together using this golden color. And what's the next thing? Let me do a factorization work here. So the 2 terms in gold. I'm seeing a plus s here and I'm seeing another x here. Okay, so it's like x is not like x is actually common to both here. I want to factorize it. So bringing out x, I'll be having y minus x. These 2 terms now, with my factorization here, I've made them to be 1 term. These 2 terms have been made to be 1 term. And what do you think is the next thing? I have 2 terms already, one in gold, the other one in white and red. So this is a term and this is a mid term. What is the common factor between the 2 terms? Anybody? X minus y multiplying this. X is multiplying y minus x. Anything common? Nothing. Nothing. Only that x minus y here is an additive inverse of y minus x. So what I want to do now is that I want to change x minus y to y minus x. Say that again. I want to change x minus y to y minus x. So let's see how it works. I'm bringing in a negative directly and minus 1. That's becoming minus s plus y. I just want to believe you understand what I did there. Okay, you see your negative 1 dividing both terms here. You see your negative 1 dividing both terms here. And you're having minus s and plus y here. Then we'll bring the value in white. So now plus x into y minus x. So let me rearrange what I have here. I can do it without this one. I can do away with this one. Then I can now have plus y minus x. Close that bracket. I just rearrange what I have here inside the bracket. I'm done with this one. So I don't need to have a 1 here. Then I'm having 3x minus 4y. Then I'm having x in open bracket y minus x. Close bracket. Now I'm looking at my work. I have already a common factor, y minus x here and y minus x here. So let me bring them here and let me bring this work up here and see how we can continue. Okay, if y minus x is now a common factor, I'm bringing it out in gold. Y minus x is here, y minus x is also here. So let me bring out a square bracket and divide all I'm having here by y minus x. Divide all I'm also with y minus x. And let's see how the whole thing is coming forth. I just believe you understand what I'm doing. This term divided by y minus x, and this term also divided by y minus x. So looking at my division on the screen, here I'm having left with me, this y minus x is coming down here, and I'm having left here, I'm having 3x minus 4y. Remember this negative is here, this negative is from here. So I'm having 3x minus 4y, then By the time minus y minus x cancels y minus x, I'm having a plus x here. I want to believe you understand the division. So if truly you understand the division, then let's move on and do away with those rough work. Okay, so here's y minus x again. Let's use this negative in red to open this bracket in white. So I'll be having minus 3x plus 4y. I just believe you understand that. Use this negative to multiply this 3x, that's minus 3x. Use this negative to multiply this negative 4y, this is plus 4y. Then I'm having outside there x. I'm having outside there x. It's already coming out. Then I'm having y minus x. Collecting the like terms that are here in the brackets. So this minus 3s plus s, that's minus 2s. Then plus 4y. So I can now have y minus x. There is no further simplification I can do again in the box. I mean in the square brackets. But there is a common factor, I think. Yeah, there's a common factor. And the common factor is just 2. 2 is here. 2 is also here. Alright. So bringing out 2. Common 2 minus 2x and plus 4y. So after the factorization, this is what I'm getting. Okay, 2 divided by minus 2x, you have minus x. 2 divided by plus 4y, you have plus 2y. Then move on and rearrange what you have in this bracket. So you're having 2y minus x. So with that done, you can just have 2y minus x and have your answer rearranged. Okay, maybe you didn't see that. Here was what I got, but these two should be in the front there. So that is the need for this movement. Right there now, you can have this answer also as your final answer. Is another way of expressing this. Actually, if you expand this, you have the same thing as this. But what makes the difference is what you change to what here is what determines what you have. I didn't mean I've changed y minus x to x minus y. Probably, I mean, I could have gotten this. So that is the operation. The one you change determines to an extent the answer you get. But I still want to say that this I want you to just do it. Make sure you don't change x minus y to y minus x. Rather, change y minus x to x minus y and see if you're going to get this. Of course, I'm sure you will get it. And also try and expand this to multiply by the golden bracket by the white brackets. Expand this and expand this as well. And let's see if you're going to get the same answer or not. Then minus a plus 2b in gold. So not to waste your time, I want to collect the like terms in this expression. So I'm having a 8s here and a minus 4 here. I'm bringing them together because they are terms of 4. Okay, then I'm seeing y terms, this minus y, minus 6y and a plus 3y. Then before I have minus everything in gold. Minus everything in gold, because everything in gold is one term. They are bound together by this bracket, but others are not bound. They can stay on their own. All these other 4 can stay on their own, but these ones, they can stay on their own. That's why they are one term. So with that, simplifying my x term, I'm having x. 8x minus 4x is 8x minus 4x is 4x. Then minus 6y plus 3y is minus 3y. Okay, then let me have what I'm having in gold. So these two terms now minus what I'm having in gold. That is the nice thing. So do we have anything in common? I'm seeing 4 minus 3y here, and here I'm also seeing 4 minus 3y to be a common factor of the two. So if that is common indeed, then let's simplify. I love that movement. Let's close our square bracket, then divide it by the factor. Okay. Well, I believe you understood what happened. I just want to believe you understood what happened. So if that is the case, then let's divide. On our division, I'll be having 1, of course a 1. This cancels this, should give 1 then. I'm having a minus a plus 2b. Then I close my bracket. Any other thing I can do in the square bracket, there is none. No like term, no point in opening any bracket again. But if you like, you can open. If you like, you can just move ahead. If you like, you can open this bracket and simplify using your negative, and if you like, you can just leave it open the way it is. I just believe you understand what I am doing. Here is the end of the lesson. I believe you understand at least a level of understanding, but you may need to go over the video again for you to have a perfect understanding of what I have done here. I have not confused you actually, but these are work units at the advanced level that you will need to know how to maneuver your way, otherwise you'll get stopped. That is mathematics for you. I want to appreciate the time. I know you've punched the like button, and I know you have subscribed if you're just a new person coming to this channel, and I know you will share the link to this video to people like you that you know they will benefit from it. Aranda. Thank you for your time. I will see you some other time, that is in our Unit 3. Stay tuned. It will reach you very soon.